Not so long ago, underground miners would take canaries down shafts. If dangerous gases collected in the mine, the fragile birds would die, allowing miners time to escape. In a similar way, Southampton scientists have found that smaller species can give an indication of dangerous changes within ecosystems.
There might be some particularly sensitive species that will be the first ones to be affected by an environmental perturbation. Very much like the canary that goes down the coal mine, it will pass out long before a human would be affected by poisonous gases. In that we're looking for the abundance and presence of these very rare species, but at the same time trying to correlate that or match that up with the abundance and presence of other species that we would want to call keystone species.
The researchers looked at a lake in China, which has seen large numbers of people coming to live around it and polluting its waters.
It's gone from a very clean freshwater lake system with lots of species of animals and plants to, in some regions, this kind of stinking green mess of algae-cloaked thick water. When you go and look in a particular lake, you'll see usually there'll be a handful of species which are quite dominant. Then there's also a very long tail of much rarer types of species. They kind of appear in the ecosystem and then disappear. We think those kind of very rare types of species are the canary species. You can look at some of the statistical changes in these rare species and you can relate it to the changes in the more competitively dominant keystone species. When you do that, you can see that the population is changing. The canary species are being kind of slowly pushed away. The keystone species are becoming initially more dominant, they're increasing in abundance. That's okay, but if you continue driving the system like that, then eventually the keystone species, they start to be impacted, and when they start to decrease, then the system is most probably entrained into a collapse.
This is what is happening at the Great Barrier Reef, where large parts of the coral are dying, and their death directly affects other species that depend on them.
Right now we're seeing portions of the Great Barrier Reef undergoing complete ecosystem collapse. That's because of the increasing rise in sea temperatures, which is called coral bleaching, and large sections of the Great Barrier Reef, especially the northern section, have bleached and they've died. Once the coral reef dies, then the fish that use that area as a fisheries, they disappear. It becomes swamped by algae again, which use that opportunity to increase in size, increase in abundance. And within a matter of weeks, you can see a sudden shift, a sudden transition between an ecosystem that would have all these abundant, beautiful corals, wide diversity of species, invertebrate organisms, transitioning to, big, thick, cloaking mats of algae. So that's a classic keystone species. Once those coral species disappear, it's very hard to get the system back because now it's being continually occupied by the algae.
Detecting early warning signs could be important to prevent an ecosystem from collapsing. But it's not always easy to see when an ecosystem is experiencing dramatic change.
There may not be many indications that the critical transition is actually happening. So people have been people have been working very hard to generate these early warning signals. So can we see fluctuations in the water chemistry that give some indication that a critical transition is happening? And you can, and maybe you can see a year or two, maybe 5 years before the critical transition itself. Unfortunately, by that time, it's quite possible that it's too late to do anything about it because so much phosphorus, so much nutrients have run into the lake that the system is becoming trained into collapse. So what we need to do is avoid the critical transition in the first place, which is why people are so interested in trying to generate these early warning signals. One of the reasons it's scary is because we don't know what the impacts, what the ultimate consequences will be of such a collapse in biodiversity. So you have to go back most probably 65 million years to find extinction rates as high as they are right now.
The researchers now will try to apply their canary theory to other ecosystems to find out if they're right. Nicole Ris, for That's Solent.